Excuse me. Excuse me. I have one question for you. Do you know Dr. Kaoru Ishikawa?
No.
Sorry. Excuse me. Excuse me. Do you know Kaoru Ishikawa?
Do I know who?
Dr. Kaoru Ishikawa?
No, I don't.
Oh, okay. Sorry.
That's okay.
Excuse me.
Yes.
Do you know Dr. Kaoru Ishikawa?
Really? I actually do. I actually need to do research for my management class. So I actually can show you a movie and go with me. One of the first individuals to encourage total quality control was Dr. Kaoru Ishikawa. Dr. Kaoru Ishikawa, a contemporary of Dr. Deming and Dr. Juran, transformed their early teaching into the Japanese approach to quality. Born in Tokyo, the oldest of the 8 sons of Ichiro Ishikawa, in 1939 he graduated University of Tokyo with an engineering degree in applied chemistry. His first job was as a naval technical officer, then moved on to work at the Nissan Liquid Fuel Company until 1947. Ishikawa would now start his career as an associate professor at the University of Tokyo. In 1949, Ishikawa joined the Japanese Union of Scientists and Engineers Quality Control Research Group. It was his skill at mobilizing large groups of people towards a specific common goal that was largely responsible for Japan's quality improvement initiatives. He translated, integrated, and expanded the management concepts of Edward Deming and Joseph Juran into the Japanese system. After becoming a full professor in the Faculty of Engineering at the University of Tokyo, Ishikawa introduced the concept of quality circles. Kaoru Ishikawa was an influential quality management innovator, best known in North America for the Ishikawa or cause and effect diagram, also known as the fishbone diagram, that is used in analyzing of industrial processes. Let's give a chance for Jeff Hedgeck to explain us how the diagram of cause and effects works.
How does this tool work? Well, you start out by identifying a problem that you're facing, and you write the effect of that problem on the right side of your paper. Alternatively, you may be doing this on a whiteboard or on butcher paper that you have taped on the wall if you're using this tool as part of a group project. Your next step is to draw a long, horizontal line as the backbone of the fishbone diagram. Then you're going to draw the spines off the backbone. These spines provide the groupings for the causes that you will be adding to the chart. In the standard version of the shop floor fishbone, you'll see 6 spines corresponding to the 6 M's. The 6 M's are materials, methods, machines, measurements, Mother Nature, and manpower. You might, however, see manpower switched out with a more gender-neutral word. In the office, you'll likely see the 6 P's: people, process, policy, plant, program, product. These categories may vary. The whole goal is to start organizing your thinking and provide some structure to the problem-solving process. Making categories helps in 2 ways. 1, it helps you improve idea generation. Systems simply help you get more causes. 2, it helps when you move into the improve step. When the causes are grouped, you'll see trends and opportunities more readily. Off each of these spines, you'll draw horizontal lines to record the causes. So let's move on to an example. But instead of looking at this from a work perspective, let's look at a problem we all face every day: getting to work on time. Many processes rely on accurate measurements to be effective. It is hard to get to work on time with a clock that is set wrong, or that runs too fast or too slow. The manpower category is basically human error when a process exists but is not followed. Be careful though. Often the reason that the process is not followed is that it's not a very good one. Snow on the highway affects your travel time. In your company, things like power outages, humidity, or a host of other environmental conditions play a role in problems. Machines are simply the tools of your trade. Your car is the most obvious machine that you rely on to get to work on time. Problems with methods are often seen as human error. In truth, bad processes are more likely to be the culprit. Materials play a big role in manufacturing. It doesn't play as big of a role in getting to work. If, however, you inadvertently chug down some decaf by mistake, you might drift back off on a couch and end up being late to work. When you're doing a cause and effect diagram, you can keep drilling down as long as you'd like. Something of a root cause analysis. Think why your car broke down, or why you drank decaf by mistake. Then add those in.
Thanks, Jeff Hedgick, for such a great explanation. There is so much to be learned by studying how Dr. Ishikawa managed to accomplish so much during a single lifetime. Thank you for listening and watching my video.